We do have a few moments for questions. I'm not quite sure how this is going to work. We have 2 mics. Are we leaving any up here for these guys? Okay, so we have 1 microphone that can be passed to any of the 3 researchers. So do we have any questions from the floor? There's a couple there, and then there's 3 already I see. So we'll start with those 3 before we ask for more show of hands. Who's going?
We'll go first.
Pat?
Okay.
All right, go ahead.
This is for Silky. We went to hear Brett Finley, so we got very impressed about how important the microbiota is. So with these mice, when you kill off the microbiota so they don't get PD, what happens to the rest of their health?
Yes, so that's an excellent question. This is, of course, a very drastic treatment, both raising mice completely germ-free from the beginning. They have behavioral changes, they are more anxious, the immune system develops differently. So there are many other changes that happen, so it is certainly not a treatment I would recommend, and the antibiotic treatment that is being used is radical. It really kills it all off. So this is absolutely not something that we should do in humans at all, but as a proof of concept that the microbes are playing a very important role, it is, of course, very, very crucial information. And our job now is to see how could that translate to humans. Are there maybe, in these initial proof of concept studies, of course, you kind of take the big hammer, kill it all. We are hoping, of course, to identify specific parts of the microbiome that might be harmful without having to get rid of everything else, but to keep the good ones and to get specifically identify the ones that might be harmful and target those, and that is why we're doing this research.
Yeah, awesome.
And of course, Brett Finley is the main collaborator here.
Yeah. No, it's awesome. I was really pleased to hear you were working with them because we thought he seemed, super. Yeah.
Very closely,
great.
yeah.
Thank you. And we've got up here at the front, Miriam.
Dr. Cresswell.
Hello, good morning.
Bacteria around the world, is it consistent around the world, or is it different in an Arctic, very cold environment versus a hot, humid equator or hot, dry desert?
Yes, so I didn't quite get the beginning, but I think you're asking about the composition of the microbiome in different locations around the world, right? Yes. Excellent question. So this falls into the many factors that actually influence the composition of the microbiome. It is remarkably stable over the course of the lifetime, but if you look at the studies that are done, the composition is different from location to location, and it's not only the extremes of going into the desert and going into the Arctic, but even in studies that are where all the participants came, for example, from the United States. There was one from Seattle, Albany, and Arizona. The microbiome was different, the composition was different between the people who came from Seattle compared to the ones who came from Albany, New York, compared to the ones who came from Arizona. So that is something amongst many other factors that we need to account for when we do these analyses, because it is really different from population to population. Like the Finnish, the Japanese, the German, the American studies that have been published, they all found slightly different results. And this is probably because their composition is different. And with that, this is a very important question. The next step is to look at not only what species do I have here, but what can they do. So we need to look at function, because the same species can have many different functions, but you can have the same function fulfilled by different species. So it might not be the actual species of microbe that we have that is the important bit, but what is important is, as a whole, how could this particular microbiome composition, for example, prevent or drive inflammation? So we need to look at function, and that is why we're doing this metabolomics part. We're looking at what is the outcome, what is the link. Does this particular composition, for example, drive inflammation or not? So, excellent question. Thank you.
Thank you. I think there's one more up here, and then we'll go over there. Oh, okay. We're going over there, please.
Hi. I just wanted to add to the exercise that the boxing has really helped me a lot with balance and strength and vigor, and it happens today that the rock-steady boxing coach for Vancouver and founder, Ali Sachs, is here.
Oh, great. Hi, Allie. Where are you? All right, so you can connect with her at the end here.
Yeah, I think all those different types of exercise are fantastic. There's no perfect formula out there. It's just kind of finding your niche and finding something that really, really works for you.
Thank you. Go ahead, sure.
I'm just wondering when a person that has Parkinson's change location, like there will be different part of the world, will that change the state or the disease?
Well, so that would have two parts. So thank you for the question. And this is really two parts to it. So the one is, does the microbiome change? And the other one, does it change their disease? So I've got many people who go down to, warm weather over the winter, and they come back and they say, it was just perfect. Things were so much better when I was in Arizona. Whether this is because people are on holidays, but I get the strong impression it is because it is nice and warm. And I wish, I had a prescription pad where not only I can prescribe exercise, which I can do, which is very important, but where I could say, okay, you go for the holiday in Arizona for the next 3 months. Can't quite do that yet. We do not know, and that is why we need to do these studies, whether the microbiome changes with that in Parkinson's. So those are questions that are just not answered yet.
Thank you. And back to this side, have we got any questions? Okay, go ahead then.
Hi. Just a question for the last speaker. You're talking about inducing dopamine release by TMS. Where were you targeting the TMS to?
So it's a great question. So we are targeting the motor cortex. So, and that's been shown. There's a group in Toronto led by Antonio Strafella that first did some of these studies in the early 2000s, and they showed if you could stimulate the motor cortex, you can release small amounts of dopamine within the circuitry. Now, it's not necessarily a treatment to actually induce enough dopamine to actually see a benefit motor-wise, but it does give us a nice measure of the system as a whole. So it gives us a measure of how that circuit is actually behaving within a patient and how we can better exploit that with exercise.
Great, thank you. And the middle there?
Hi, I personally want to thank all the speakers. Every time I come, you guys are just amazing. So that's number one. The second question I have is more to do with genetics. My husband has Parkinson's over 20 years. His siblings were tested with their blood because his mom had MS. And now my son, when you're talking about the gut, has now been diagnosed with acute ulcerative colitis. So I'm wondering if it's the correlation is all through it, and if so, is there anything we can do for future generations regarding get them tested earlier, or maybe it's a combination of all of you? I'm not sure.
Great question. So it's a combination of different factors. Yes, there could be related, even different diseases, alteration in the same protein, in the same circuitry could give different diseases that may be connected. We actually see sometimes connection from very different diseases like Parkinson's disease and Alzheimer's diseases. BPS certified, the protein that I'm studying is actually involved genetically in Alzheimer's disease as well. So yes, there could be correlation. It's only a small percentage of Parkinson's is actually genetically caused by genetically mutation. So we're talking about like very, very small percentage. So it may not be. So the issue here is that yet, even with the technology that we have, it's still quite expensive to screen everybody for genetic mutations. So yes, we definitely do it when there is suggestions in the family that could be something that is carried on across generation. But if there is no reason to suspect so, we usually don't go for screening, but there are definitely a lot of labs, including ours, that are looking for people that will want their genome screened, and in certain situations we can, according to funding, obviously, and if it's possible economically. So please do go on our website, which I believe is also on the Parkinson Society British Columbia website for more information. We have a genetic counselor, so you can always contact. And it may not be the case where you need screening, but it's always good to get information about it.
Great, thank you. Any other questions? And Miriam's pointing to her clock for time. So we take
One
one
more.
We'll take one more.
Hi, this is about, I think, genetics as well. We have a grandson who, he's 15 now, but the last few years he's saying he's lost his sense of smell.
Oh dear.
And his maternal great-grandmother had diagnosed with Parkinson's. His maternal grandfather has now been diagnosed with Parkinson's. And his paternal grandfather, sitting here with me, was diagnosed with Parkinson's plus, multiple systems atrophy. So I'm wondering, should we be now with this grandson, who is otherwise perfectly wonderful, except for his sense of smell, should we be looking at your genetic website or coming to your, control group maybe, or not control, but to get some kind of insight into what's possibly happening?
That is possible, yeah. I would recommend, yes, maybe try to email us for more information. Again, like it may not be the case. It's quite often actually the same people in the same family present with Parkinson, but they're not genetically related. But there is this possibility, so yes, I will recommend just getting information. Getting information, it doesn't mean that you're never necessarily gonna be screened genetically, and it's completely free. So like, feel free to contact us for more information. Maybe, yeah, you can add something.
Yeah, just to say from a clinical perspective, there does seem to be, but one generation up from your grandson, 2 generations up, there seems to be a lot of Parkinsonian disorders in the family. So I think just for the whole family to look at that is certainly worthwhile. It seems to have skipped so far the middle generation, and your young grandson is much younger, so it'd be somewhat unusual. I mean, that would be a very big difference in presentation between, older age presentation to something that would be very, very young. And as a clinician, I really have to say, before you start worrying now, there are many, many different causes for losing your sense of smell. An isolated loss of sense of smell in somebody who's very young, don't start worrying about Parkinson's at this point. Yes, have the family, you can participate in research, that's a great idea, but I don't want you to start worrying about your grandson now unless there is anything else. But if it's just sense of smell, there are many other reasons. This is just one piece in the puzzle, but it always is a complete picture that we're looking for, not just one piece.
That's great. Thank you for those reassuring words. We will have the researchers here for a few minutes, so if people do want to come up and speak to them one-on-one for a little while, we can manage that. And then we're taking them to another function. So I just want to, again, thank all 3 of them. You can see the breadth of knowledge and expertise that we have right here in British Columbia, Vancouver. And they are working hard. They're very passionate. They're part of a much larger team, and it's very inspiring to hear the work that they're doing and to learn. It's quite some innovative twists as we learn more. There's different aspects that the researchers think about. So I do encourage you to participate in the research, and Matt's got the PPRC website up there. We also have their research and how to get involved posted on our website. And I'd just like to emphasize what Silke said. It's not just the person with Parkinson's. They're often looking for controls. So if you as a care partner are going anyways out to UBC with your person with Parkinson's, perhaps think about volunteering to be a control. Wouldn't that be perfect?
That would be fantastic. And I should say, particularly for the microbiome study, because there are so many factors influencing the microbiome, people who are care partners, so who are not blood related, but are living in the same house, are eating essentially the same diet, would be of particular informative interest, because they have many shared parts that are so difficult to control for otherwise.
Yeah. So just to clarify, you do have to go to the clinic, right? So you have to be able to make that trip out to UBC in order to participate in the study?
Yes, because there is an in-person assessment. It takes 2 hours. If you know you're coming up for an appointment, that can sometimes be coordinated, but that could become a tiresome visit. So yes, you have to come to UBC for now. There might be other projects in the future where we don't need that, but for now, yes.
And Matt, I know you were doing some outreach for some of the stuff. Did they have to still come out to the Vancouver UBC campus to participate in your studies?
For the scanning, yeah, for the exercise study, all the scanning and baseline stuff is conducted at UBC, but we do have sites throughout the greater Vancouver area for our exercise program. We just opened a site out in Maple Ridge. We have one on the North Shore. We're opening something out in Surrey. So we do have some options for people who don't necessarily need to make 3 months worth of trips to UBC, but just a couple at the beginning and a couple at the end.
Okay, thank you. And Stefano, you said something about you're looking at cell biology as well as the animal studies. Are you actually needing human subjects as well, or not?
Well, mostly we do cell cultures from mice. So we have our own mice, and we can grow cells from these mice. We are currently working on stem cells as well from patients, but we get them from patients that we know have the mutation.
Okay.
So just to bring it back to the previous questions, we're using genetic information as a tool to identify what's happening. These different genetic mutations are causing the same Parkinson disease. They present in the same way as idiopathic Parkinson disease. So the genetic is only used as a tool to understand what's happening earlier, because we can then
So
model.
just having people generally volunteer to participate is not
It's not
going
really
to be helpful to your
we
research.
were more basic neuroscience. We're not
Okay.
really
All right.
interacting with patients.
Well, again, I'd like to thank all three of you for coming out this morning and presenting such interesting and innovative efforts to try and help people with Parkinson's. Thank you. And thank you to all of you. It was a great turnout here today. We really appreciate your support and participation. And please keep us in mind. Keep looking at the website. If you're not linked up with your email address, please connect with us, because we do send out little updates periodically. And just keep in touch. Thank you very much. Don't forget to vote May 9th and come out to our June 3rd conference. Have a good day.